solving this particular challenging question, which says that we're given a sample here of seawater that has a density according to this statement to be 1.027 grams per centimeter cube at 10 degrees Celsius, which we're going to write right here for this particular container that represents our seawater. That is the first information here. The next information here states that we have the particular mass percent of the sodium chloride in this standard seawater to be around 2.67%. And the next information that is given here states that given that the sodium chloride is 39.34% sodium by mass, so that is something to be aware of, so is 39.34% by mass, and it says that the mass of a single sodium atom is this particular value, and this value is less than 1. And the question here says that you should find the maximum of sodium in terms of the mass. How much of sodium in terms of the atom is in the seawater of 1.5 liter. So here we're going to solve the following in 3 steps, which includes the following. Now for the solution, the first step includes the following. We need to be able to go from our density of the seawater all the way to determining the mass of the seawater. But here is the catch: we need a specific variable to accomplish this particular pathway, and this variable here is what is given the question, which is the volume of the seawater in question. And so what are the things that you should know in terms of the skills to arrive at the desired outcome? The skills that are required include the following. First is that you should know the relationship between centimeter cube in terms of the equivalence to the liters and how this is equal to milliliters. And so the golden numbers in terms of the ratios are as follows: 1000 centimeter cube, and this here is equal to 1 liter, and this is equal to 1000 milliliters. Now this here is going to be accompanied alongside the density formula, and the density formula is equal to the mass divided by the volume of that specific object. Now this question here allows us to use the 2 variables, which are the density, and we need to do what with the density? Multiplied by the volume in order for we to find the mass of the seawater. And so you can accomplish this, remember, by cross multiplying, and that takes you to that path right here. Now once we are able to have these formulas set up, we can now incorporate this into our problem to find what the answer is. And to accomplish this, what we need to do is to determine the mass of the seawater. What we have is our density first, which is in this case 1.027 grams in this case per centimeter cube, and this here is going to be multiplied by what? The volume, and the volume here is what? 1.5 liters over 1. Now here is the thing: we need to get our values in what? Grams, but our units for volumes do not agree, so we need to eliminate the units for the volume, and to do that we use the equivalence of just the centimeter cube to the liters. And so this looks like this. We have to put our denominator to be the liters to cancel out the liters, and this here is going to be over 1 liter, and our numerator here is going to be the centimeter cube, which is in this case 1000 centimeter cube. And once we have this, we can now cancel out things and multiply our numerators, and this will give us our final value in grams for the mass of seawater that is in that volume 1.5 liters, which is equal to 1540.5 grams of what seawater that is present in what 1 liter 1.5 liters of seawater. Now once we have this, we can use this here for our step 2. Now for step 2, what we have to do is to go from the mass of what the seawater that we determined all the way to determining what the mass of sodium in the seawater. And now for we to accomplish this, the first thing is to, from the mass of the seawater, incorporate it with the percent of the mass of the sodium chloride present in the seawater, and this here will enable us to determine what? It will enable us to determine the mass of sodium chloride. And once we have this determined, that is our hope, we're going to incorporate this to the percent of biomass of what? The sodium in the sodium chloride, and this will enable us to determine the mass of sodium in the seawater. And what are the things you need to know here? All that you need to know is ratios, and we talked about ratios. Make sure that the percent are based on the mass. Our focus is on grams. Everything should be in grams. And so to accomplish this is how the setup is going to look like, going from this all the way to the final destination. And the first step is looking at this here. We are going to write our mass, which is in this case our mass for our end goal to be mass of sodium in seawater is equal to what? First, the mass of the seawater will determine to be 1540.5 grams of what? Seawater, and this here is over 1, of course. Now here is the next step. The next step is to multiply it by the ratio of what? The mass percent of sodium chloride. Make sure it's in grams to what? Grams. And so sodium chloride here is given in the particular question to be 2.67 grams of sodium chloride in what? Because it's percent, it is going to be out of 100 grams of seawater, and this here is multiplied by what? The next thing here is that will give us our mass of sodium chloride, but from there we need to find the mass in seawater. So we need to multiply this value result when we multiply these two numbers and divide by 100 by the ratio of the mass of sodium in seawater. And this here is the ratio to be what? In percent is 39 point what? 39.34 grams of sodium in what? In sodium chloride is considered, because it's percent, in 100 grams of sodium chloride. And so once we have this, we should be able to determine our value for the mass of sodium in seawater to be 16.18 grams of sodium in seawater. And so this value here, you know, is in grams. We're going to make some little tweaks on this to get us to the final answer on our third step. And here is the final step, where we are going to be going from our mass of sodium in seawater, which is in this case what we determined from step 2, and we're going to get to the end goal, which is to find the other variable that is asked in the question, and that variable is to determine the number of sodium atoms in that 1.5 liters of the seawater. And so in order for we to accomplish this, there are two steps as well within step 3. And the first step is, remember to convert this from grams to kilograms. And what we're going to do is divide by 1000, and I get our mass of our sodium in seawater to what? Kilograms. And once we have that particular value, once we get to that value, the final step is to do what? To go from our value in kilograms to the mass of our sodium atom that is given in the question. And so once you're able to recognize these two steps, we'll be able to determine what the final value is. And what do we need to know? The same thing from step 2 is what we're going to apply in step 3, and that is ratios. And so this includes the following. First step is make sure that your subject of the equation is in terms of the number of sodium atoms, and we need to follow our first step, which is write our mass of sodium in seawater, which we determined from step 2 to be 16.18 grams of what? Sodium. And this here over 1 is multiplied by the unit equivalence of grams to kilograms. And so this here is for 1 kilogram of sodium, this is equal to 1,000 grams of sodium. And so we're able to convert, in this case or step here, from grams to kilograms. That is the purpose of this. Now we want to move on to the next process, which is step 2, which is incorporate our mass of our sodium atom. And in this case here, we have this to be multiplied by what was given the question to be for 1 atom of sodium. This here is equal to what? A really small number, 3.817 times 10 to the power of negative 26 kilograms of our sodium. And so our final answer to this question is going to be what? 4.2. Let's round this to the nearest hundredth. 4.24 times 10 to the what? 23 sodium atoms. And so this is how many atoms that is present in what? In 1.5 liters. And in terms of the mass is determined from our step 2 to be 16.18 grams of sodium that is also present in the 1.5 liter sample of the seawater. Overall, I hope you found this really informative. Please hit the comment down below. Let me know your thought about this particular stepwise method of tackling problems that may be a little bit challenging or a little bit more advanced, but relying on simple techniques that you may have gathered from previous subject area in order for you to solve problems in a much more ordered and organized way. All the same, see you all on the next one. Stay smart as always and believe in yourself.